So in the chat box, we have pasted the link of the link for downloading JAMOVI. Those who are joining today newly, kindly download this. There are two options available. One is solid and another one is current. Kindly download the solid version. We'll start in a minute. Okay. Team Planet, kindly start the session.
So good afternoon and welcome to one and all. I'm Sreshi, the assigned moderator from Planet. Planet is India's most trusted and widely used digital platform with multiple enriching services for doctors. Planet is very proud to be a part as a digital partner for this event organized by All India Institute of Medical Sciences Patna, and the topic of today's session is binomial logistic regression. So let's begin today's session, for which I would like to invite Dr. Venkatesh sir to take over. Please proceed with the talk, sir. Over to you, sir.
Thank you so much, Shreyasi. A very good afternoon to all. It's my pleasure to welcome you all to our sixth webinar on the series Data Analysis Made Easy with JAMOVI software, hosted by the Department of Community and Family Medicine, AIIMS Patna, in collaboration with Merit India and Client. Myself, Dr. Venkatesh Karthikeyan, Community and Family Medicine resident from AIIMS Patna, and I'll be the moderator for today's event. I'm thrilled to see such a fantastic response from different parts of the country. We had got registrations, and as we all know, data analytics has been an increasingly important tool in the healthcare industry, allowing doctors to analyze and interpret vast amounts of data to make informed decisions and to improve the patient outcomes. This webinar series aims to provide insight into data analytics and its application in healthcare. I would like to thank our HOD, Professor Dr. C.M. Singh sir, and Dr. Samshad Ahmed sir, Associate Professor of Department of Community and Family Medicine, AIIMS Patna, without whose support this webinar series would have not been possible. Now, I would like to introduce our resource faculty, Dr. Pragya Kumar ma'am, who actually does not require any introduction. However, for those who are new here, Dr. Pragya ma'am is an additional professor in the Department of Community and Family Medicine, AIIMS Patna. Ma'am has over 50 research publications to her credit and has trained over 5,000 researchers across the globe through her workshops and webinars. With this short introduction, I would like to welcome Dr. Pragya ma'am. Over to you, ma'am.
Thank you, Venkatesh, and thank you, Clarinet team. So I would start today's webinar that is on logistic regression, and we'll be focusing entirely on the binomial logistic regression. And in subsequent webinars, we may have webinar on multinomial and ordinal logistic regression, which are again a type of logistic regression. So let's begin this webinar with the example, and we all request you to put your idea or comments in the chat box. And those of you who have attended our linear regression workshop did the same exercise. But for those of you who could not, just to exemplify the difference between the linear and logistic, this example is being placed. So you can see here there are two columns. So there is a distance in one column, which is the distance in kilometer, and in the second column it's the taxi fare. So if you see this data, for 1 kilometer the fare is 100, for 2 kilometer it is 110, for 3 it is 120, and so on. So based on these 5 data set, can you make a formula to predict taxi fare from this data set? Like if you have these 5 observations and you have to make a model or prediction, how are you going to proceed? So all of you, please try at least once. What will be the formula? Can we see the chat box? I think it's everyone. Okay. So maybe I am not seeing messages. Maybe there is some issue. So let's go ahead. If you see this, the taxi fare can be predicted using the formula 90 plus 10 into distance traveled. And if you see here, if you multiply this distance traveled with 3, which is the 3 kilometer here, so 90 plus 10 into 3, it will be 120. Similarly, if you come to this 5, so 90 plus 10 into 5 will be the 140 kilometer. So if you have to place this in the form of a regression equation, which is the linear regression equation, then this y will be the dependent variable, and you have to predict this using a explanatory variable, that is the distance traveled. This A is a constant here, which is known as the intercept. And this B is the coefficient, which we will see later in the table. And this coefficient, when you multiply this coefficient with this independent variable, you get the value of dependent variable. So with the help of this equation, we can predict the taxi fare for 5-kilometer distance travel. And in this case, can you see that the prediction equation, which we have predicted, and the actual, that is same. So the predicted fare is equal to the actual fare. Do you agree with this? So yes, we can see here, this is 5 and actual, whatever you will calculate, that will also, okay, so I have started seeing the messages. That means we can interact with each other. So thank you, Neha, Ashish, Prachi, Rajesh, I can see few names. And then if you go ahead, again, we can make this equation in the form of this linear equation, which is the y is equal to a plus bx. And this is a simple linear regression equation where we plot a line of best fit. Actually, when we announced this webinar, we thought that we should have done the linear regression before this logistic regression. But since we made an announcement, that's why we thought maybe we'll do this linear regression next as a next webinar, because if you understand this linear regression concept of logistic becomes a little easier. But again, that's why I have included few concepts of linear regression here also. And this is one example where this linear regression equation, you try to form a regression equation and it gives you a line of best fit. And what do I mean by line of best fit? That means the residual. Yes, Dr. Rajesh, I will be explaining the difference between the logistic and linear regression. That's why just hold on for a few minutes and then you will be able to understand. So here y. So y was what? It was the taxi fare. So if I ask from you people, taxi fare is a which type of variable? Is it a continuous variable or is it a categorical variable? Yes, can you write in the chat box? With the same example, if I have to predict the taxi fare using the kilometer traveled. So taxi fare, yes, it is a continuous. So since it is a continuous, whenever the dependent variable, in this case, which is the taxi fare, is a continuous in nature, we call it as a linear regression. And if there is a one explanatory variable, like in this case, there's only distance traveled. So if there is a one variable, we call it as a simple linear regression. If there are more than one variable, we call it as a multiple linear regression. But since here I have given only one explanatory variable, which is the distance travel. So this is an example of simple linear regression equation. Why simple? Because there is only one explanatory variable. And why linear? Because the dependent variable in this case is a continuous variable. So we'll go ahead and we'll understand how this logistic is different from linear. Now let's change the value of data in our previous example. So in the previous example, you saw that there was a definite pattern. But here if you see, for 1 kilometer, it is 96 rupees. For 2 kilometer, it is 112. For 3 kilometer, 123. For 5, it is 170 and 2, it is 106. So by seeing this data, it is not possible for me to derive an equation. Volume. Okay, so you are asking me to increase the volume. So let me check the setting. Mic check, mic check. Is it okay, Venkatesh, now?
Yes, ma'am. Yes, ma'am. I mean, it is. It can be boosted, I suppose, ma'am. Like last time.
Yeah, but I'm trying to scroll this, but it is not happening. Just okay. Let me check. Oh yes. Yes. Is it better from before?
Yes, ma'am. Yes, ma'am.
But Dr. Kritika is writing and everyone is writing. It is okay. Okay. Thank you. Thank you to both of you, Venkatesh and the other doctors. Thank you. So you can see here that this formula, now it is difficult for me to derive a formula for this because I'm not very good at maths. So I cannot make a formula. I'll have to use a software. So if you put these values in any software, maybe in Excel or in JAMOVI, in SPSS, and if you try to form an equation out of this, then what will be the equation? Let's see. So in this case, the equation will be like this. So the intercept, this I have entered these 5 data in JAMOVI, and now I can see that this 72.56, what is this? So basically this is the intercept or the constant, and the estimate, there's an estimate column, when we'll see what is this estimate column, and then there's a distance traveled. So now I can predict this taxi fare using this constant plus 18 into 8. I have taken it as a 18.8 multiplied by the distance traveled. So this is my linear regression equation, and I can find out A and B easily. So this is my prediction of the taxi fare. And now I can predict the taxi fare for 5 kilometer distance. So all of you, please do the same. You calculate the fare now with a 5 kilometer distance. All of you, please do it on your phone and please type on the chat box. What is the taxi fare for 5 kilometer distance? So it will be 72.5 plus 18.8 multiplied by 5. But I want all of you to do this and type in the chat box. So 160, Josephine has written first. So 166.5, then 164. So I think majority is writing 166.5. So predicted fare is the 166.5, but the actual fare is 170. So now the difference between these two, how will I name it? So it is known as the residual. So I just wanted to introduce the term residual, although the concept of residual in case of logistic is a little different from the linear regression. In linear, it is very much, you can say, like you take the actual value. But we'll see in logistic, actually, it is done on the calculated probabilities. So we talk in the term of probability in case of a logistic rather than the actual value. So now can you understand the difference of, there is a difference of 3.5 between the actual value and the predicted value, and this is known as the residual. Now, if you take many more variables, like if the traffic is slow or smooth, it is a weekend or no weekend, weather is humid or pleasant, then the fare is again determined by these factors. So then it will become a multiple linear regression because I'll take more variable instead of the kilometer travel. And there are 3 more variables, which is the traffic, weekend, and weather, which has been added to this. And then there's a calculation of this taxi fare. So now I can make a equation like this, taxi fare with A, which is a constant. And again, there are coefficients for each of these explanatory variable. So B1 is the coefficient for distance travel, which we have seen in the previous example. Then B2 is for the traffic, B3 will be for the weekend, and B4 will be for the weather. But in this case also, you will see that I am predicting the taxi fare, this one, which is a continuous variable. So still, I'll go for a multiple linear regression because it is a continuous variable. Now, here another example, you can see here attendance. I have to see, predict the marks. If a student is attending classes, then how much marks he will get. So you can see, or on the basis of duration of exercise, how much will be the fasting sugar. So can you find any relationship between the duration of exercise and fasting sugar, or between the attendance and marks? So you can see that the people who are having more attendance, like here you can see 80%, 80. So they are getting more marks. Individual attending less are getting less. But if I want to make a prediction equation, I'll have to use the linear regression equation. Similarly, here also you can see the person who is doing exercise for more number of minutes per day, having less sugar, and doing less, having more sugar. So based on the observation, we can predict the marks of a student by the attendance, and we can predict the fasting sugar by the exercise duration per day. Now, if I, again, here also I have added one more variable. You can see male, gender, male, female, and here also I have added one more variable. So now I'll have to look for that. So till now, we have tried to predict the values of a continuous outcome. So the closer the predicted value, the better will be the equation. And that's how we call how good our model fit. You may be seeing in the literature, reading, or you may be writing your results, and then we talk about the model fit. So what do we mean by model fit? So it is simple. The lesser these residuals will be, the more accurate your prediction will be. Like again, go back to the example of taxi fare and the distance traveled. So the lesser the residual, means whatever you are predicting, it is the almost near, the actual will be very much near to those predicted, then we call that the model fit is very good. Now, let's check. In this case, if we wish to predict fasting blood sugar level based on gender and duration of exercise, we recruited 10 persons, we asked their gender, we asked their duration of exercise, and measured the fasting blood sugar. So in this case, if I ask from you, we have followed 3 models. We have calculated 3 models. This is model 1, this is model 2, and this is model 3. So I'll be talking about all these concepts like goodness of it, badness of it. Don't worry. At the end of because the total duration of webinar is 90 minutes. So maybe at the end of 80 minutes, if any concepts are still left, you can type in the chat box and we'll answer all questions, whatever questions are there. But let me finish that, because maybe you will get your answers while I am moving ahead with the webinar. So you can see there are 3 models, model 1, model 2, and model 3. In this case, you can see here, now focus on these 2 only, the predicted and actual. You can see these last 2 columns. So in each of these 2 columns, please focus on the predicted and actual. And it is a request from all of you, please see these 2 columns of all these 3 models and tell me. So right now, I'll start with model 3. So if you focus on model 3, this is the predicted, this is the actual value, and this is the predicted value. So can you see what is the residual in this case? Can you all see and tell me in case of model 3? Zero. Yes, you are right. Yes. So in practical, is it possible? So yeah, if you see, this is not possible at all, this third case. Now coming to model 2. So if you come to model 2, what is your idea? This actual and predicted. This is 96 and this is 130. This is 132 and 90. So there is a huge difference between actual and predicted. So if this is the case, it is stuck somewhere. Why these slides are not moving ahead? Somehow. Oh, yes, now it is okay. Yeah, thank you. So you will see here that this model 3 is ideal, but it is not practical. In this case, yes, Jatin, Prachi, Rajesh, they have written, in case of a model 2, the residual is very high. So the best model is the model 1. You are right. So for linear equation, there are certain assumptions which are required. And we know that there is an assumption of linearity. So yes, you are right. Model 1 appears practical. And then if you come about for the assumptions, so all these modeling, before we model any variable, it is very important to check for the assumptions, because if the assumptions are not met, it is not going to be accurate. Your model is not going to be accurate. So one of the assumptions of this linear regression model is the assumption of linearity. Means if I have to plot this linear regression equation between the duration of exercise and fasting blood sugar, then when I plot this scatter plot, the relationship should be linear. Similarly, there are other options like residuals, which you have seen that they should also follow normal distribution. So now if we complicate this scenario further, now instead of this fasting blood sugar, you can see here, initially I have used this example of fasting blood sugar. But now instead of fasting blood sugar, I have taken one categorical this thing, which is the diabetic foot. So you can see here my variable is the presence or the absence of diabetic foot. And here also out of 100 marks, I have categorized these variables as the students who passed or who did not pass. So now my dependent variable is a categorical variable. That means I want to predict the diabetic foot in a patient on the basis of the duration of exercise and gender. Or I want to predict the marks of whether the student will pass or not on the basis of the attendance of the student and the gender of student. So now how this is different from the previous example? Yes, all of you please write something in the chat box so that I can see that you are listening. So Bilal has typed the last one. So Hardik Kumar is writing discrete data. Sovnik is writing outcome is categorical. Prashant is writing outcome is binomial. Yes. So here you can see that, yes, agree with all of you that we have categorized this as a categorical: pass, not pass, present, absent. So instead of taking the marks or a blood sugar, now I am talking in terms of a categorical, whether presence of diabetic foot or absence of diabetic foot, or pass or fail. So now if I have to model like whether a student will pass or not the marks, then I'll go for the logistic regression, and that is the binomial logistic. So in the beginning, I think Dr. Rajesh asked this question, what is the difference between a binomial and a linear regression? So whenever your dependent variable, and you can do that, like you can categorize your dependent variable. There are many times that your natural variable is a categorical variable. Like we'll see in today's example, the death. So death is a categorical variable, death or no death. But many times we have got a continuous variable and we categorize it as a categorical variable, like blood pressure. If you have a blood pressure, you categorize it as a hypertensive, non-hypertensive. Similarly, blood sugar. You diagnose blood sugar on the basis of some value. But again, you can categorize it having diabetes or no diabetes. So here, those continuous variable have been categorized it as like Shalini is writing BMI. So you can make it like obese or non-obese, similar situation. So in this case, how will I form a linear equation? So there it was very easy for me because it was a variable which is a continuous in nature, which was a blood sugar. But if I have to use this, and again logistic regression, because it is a prediction, so it uses again a equation. Remember, all predictions, right now we are concentrating on the linear and logistic, but there are many other predictions, and there you will find like quadratic equation, the square, and all those forms are also used. We are not going into those detail, but whatever prediction, if you are making a model, there will be an equation of that model. So now if I have to fit that logistic regression model into linear regression, how will I fit? So I will write, if I want a linear equation, so I will write whether diabetic foot yes or no, and then I will write A, which is the constant or intercept, plus B1 into gender, plus B2 into duration of exercise. Do you agree with this? Like writing of this? Yes, Prachi, we'll come to that possibility. You are right. But we are going slow to build up those concepts. So maybe it will take a while to reach to that concept. So again, if I have to write like, if I have coded absence of diabetic foot as 0 and presence of diabetic foot as 1. So what will I write? I will write 1 whether occurring and 0 whether not occurring. And then I'll write these equations. So linear equation is not possible here. Why? Because there are only two outcomes, which is a binary outcome, either 0 or 1. So linear regression equation is not possible, which we have seen in the case of taxi fare or blood sugar or the marks obtained in the exam. So now it is only possible when the outcome has a continuous. Now what should I do? So what like just Prachi was saying, we calculate the probability of occurrence of those outcomes. So taking all the independent variable, the software calculates a probability. So, you know, if you can recall from your high school maths, probability is something as like event occurring out of total events. So in this case, we'll see how this software does it. So in this case, you can see that there is a gender, there is an age, duration of exercise, and the presence of diabetic foot. So how will I say this? So I will say this: what is the probability of a male person who is 32-year-old doing a exercise of 50 minutes per day? So what is the probability of occurrence of diabetic foot in this person? So I talk like this. Again, if I have to explain the third case, how will I say this? So I will say, what is the probability of a female who is a 55-year-old female and doing the exercise for 39 minutes in a day? So here now we'll see. So this is the actual one, actual whatever has happened to this person. And now that data calculates the software calculates the probability based on this. So likewise, for each case, there will be a different probability. For each of these combinations, there will be a probability calculated. In case of a linear regression, it calculates the actual value. Actual value means a continuous value. But in this case, a continuous value is not possible. So it calculates a probability. So you can see here that these are the actual happening, which is 0 and 1, and this is the predicted probability. So you can see the predicted probability in this case, it is 0.05. This is 0.64, 0.69, 0.16, and so on. Right. So these are the predicted probability. Predicted probability taking all these variables together. Now, on the basis of these predicted probability, we'll see how to classify this. So we all know that the value of probability ranges from 0 to 1. Do you agree with this? Probability value always ranges from the lowest will be near to 0 and then the highest would be till 1. Yes or no? So yes, Dr. Rajesh, Khima, Prashant, Monica, all of you are correct? Yes. So now, in case of an actual occurrence, we write 0 if there is a no chance of occurrence. So the probability value will be 0 if there are no chance of occurrence, and probability value will be 1 if there is a definite chance of occurrence. Do you agree? Yes or no? If there is a no chance of occurrence, the probability will be 0. If there is a definite chance of occurrence, the probability value will be 1. Now, what to do with these values like 0.12, 0.93, 0.55? So 0.12, how will you take this? Chance of not occurring or occurring? All of you, please write in the chat box. I'm asking for the first example, which is the example, which is the... So Kritika is writing negligible chance. 0.2, Jayaraman is writing less chance. Shalini is writing chance of occurring, not occurring. Okay. Now, what is your opinion regarding 0.93? Yes, 0.93. All of you are correct, like Neha, Tanvi, Shah SK, Rajesh. Yes. So with 9.2, it is the high. So yes, you are very right. But now what to do with this 0.55, which is in the middle? So 0.55 is the middle value. What to do with that? Yes, you were right. Moderate. I know. Surobhit Nayak is writing. Agree. Swapnil is also writing. Equivocal. Kanhaiya. Prashant. Shabnam. Moderate. Okay. Moderate chance. Yes. So 0.12, you are right. You have perfectly answered these three questions. Nearly no chance in case of a 0.12. 0.93, yes, nearly definite chance of occurrence of outcome. And now coming to 0.55. Now 55 is difficult to decide. And it should not be, Rajesh is writing, should not it be plus 2 SD outlier? We'll see, Dr. Rajesh, how to decide for that. Ultimately, you can decide for a cutoff, but how this software decides. So basically, how to resolve this dilemma if the values are in the middle, because then we are not sure how to do that. So we need to set some rule for this. So there is a rule which the software decides, and then he has given you also the option to decide. So generally, if you want to increase or decrease your cutoff, you can do that. But the software decides it at the value more than equal to 0.5, the outcome has occurred. And if the probability value is less than 0.5, then the outcome has not occurred. So have you understood? Either whether it is a software or it is a JAMOVI or any software, in the background calculation, the software calculates the probability, and if the value of this probability is less than 0.5, then he takes it, the software, it takes it as the outcome not occurred. If the value of probability is more than equal to, even if it is equal to 0.5 or more than 0.5, then we say that the outcome has occurred. But again, in both SPSS and JAMOVI, there is an option when you can change this cutoff. And we will see later, you can have this area under the curve because we plot, you can check the sensitivity and specificity of model. So by changing the cutoff, like we do for a ROC analysis, you can see the diagnostic accuracy of your model also. We will see these concepts once we see the data set and perform the hands-on. So here, the software decides on the basis of 0.5. Less than 0.5, outcome has not occurred. More than equal to 0.5, outcome has occurred. So now, we have now understood that this software calculates the probability, and on the basis of probability, it gives the outcome as the outcome happened or not happened. But many of you who have done the logistic regression before, don't you ever feel surprised, or did you ever question to yourself that how come this odds ratio is coming into the picture? How come this odds ratio is coming into the picture into logistic regression, whereas in linear regression, we actually don't talk about it at all. So now we'll see how come this concept of odds, or the name, we call it as a logistic regression. If you see the spelling, it is LOGIT, logistic. So we'll see there is a link function which is known as the logit. And it uses this link function to meet certain assumptions. And we'll see how it uses that. So in the previous question, we have seen the probability. So now you can, instead of this diabetic foot yes and no, you can write that probability of diabetic foot, because now what I did, I have converted a categorical variable into a continuous variable. Do you agree with this or not? So now things are easy for me, isn't it? If instead of this diabetic foot yes and no, now can I write this probability of diabetic foot is equal to this equation? So Samarendra, Tokveer, and I can see a few more people answering yes. Prachi, Pradeep, Shabnam, Neha. Yes, you all are right. So now I can write probability. And then there is something which is a continuous, because probability will range from 0 to 1. And that's why I have, instead of that category, I have got some probability. But still there is a problem with probability, because probability, what is the rule? It can never go beyond 1 and it can never be less than 0. But if you remember that linear equation, for linearity, you need values which should go from minus infinity to plus infinity. If you restrict these values, then the linear assumptions will not be satisfied. Because for this equation, the linearity assumption, where we find that the scatter plot between the two variables should be there. Yes, gender is there, but maybe for independent variable, generally we take linearity equation if there is a continuous variable as one of your independent variable. If there are only categorical variable in your logistic regression as an independent variable, then you may not need to put the assumptions of linearity, which we check here as one of the assumptions. We'll see that. Now, coming to this, so you will see here that this, and here I'm talking about the dependent variable. I'm not talking about the independent variable, because the minus infinity to plus infinity, the linearity of this dependent variable, I have to check the linearity of dependent variable with each of these independent variables. So for gender also, it will be linear. Definitely it will be with 0 and 1. There will be two categories, but we can plot it. Now for linearity assumption, and this I am talking about the dependent variable. So it should go from minus infinity to plus infinity. So if you convert this probability into odds, so odds can range from minus infinity to plus infinity. So how we can convert the probability into odds? Yes, can you people guide me? How can I do that? Any one of you? If I have to convert probability into odds, how can I? Is there any formula? Log of probability. No, it will be one step higher. Yes, by ratio. Agree. Dr. Makwana has written. So, yes, you are right. Probability is equal to 1 by 1 plus odds. But yes, Prashant has written correctly. P divided by 1 minus P. Yes, Prashant, you are absolutely right. So now if I have to convert this probability into odds, first tell me why I am converting it into odds. Yes, if you are understanding whatever I am talking, why there is a need to convert probability into odds. I'm asking questions in between. Prachi is asking, linear regression will estimate the dependent variable when there is a change. Yes, that's okay, Prachi. But my question is, why we are converting? So Janam is writing, so the linear assumptions can be met. And what is the problem with probability? Yes. So doctor, I think name is not here, but he's right that it ranges from 0 to 1 only. And for linear assumptions, we need a range of variable. We cannot restrict between 0 to 1. That's why we are, yes, agreed. Dr. Janam is right. We need those two extreme values. That's why we are converting it into the odds. So now we have converted into the odds using this formula of P divided by 1 minus P. So like if the probability of occurrence of a diabetic foot is 0.75, what will be the odd? Odd will be 3. So you can see that odds is now going beyond 1. So there is a range of value of odds, and you can see that. So this, you all can do that in Excel or in this software also. It gives you the predicted probability, and we can calculate the predicted odds. So this is the predicted probability, which is 0.055, and this is the calculated predicted odds. We'll see how to calculate this based on the formula P divided by 1 minus P. And now you can see that there is a value, there is a odds ratio, which is 25 also here in this case. And there is a odds ratio, which is less than 0, which is the, no, here it's not less, but it can go like less than 0 also, minus infinity to. So it can range from 0 to infinity. Because you will see odds ratio can never be negative. Odds, not odds ratio. Odds will not go less than 0. But again, we need a value. We should go less than 0 also. So for that, we are taking this function. And also we'll see that this is not symmetrical. How is that? We'll see. So here you can see this is the predicted odds. So we can have a linear equation. Now, instead of probability, what I have written? I have written odds of diabetic foot is equal to this. It will be a constant, and this will be again those three variables. So now you have seen that in the dependent variable, initially we have kept a category, but we have seen that this is not possible. So we have converted into something known as a continuous, which is the probability. But again, there was a problem of probability because it cannot go more than 1. So for more than one issue, we have calculated odds. But again, that problem of 0 is existing. And again, there is a problem of odds, and we'll see that is not symmetrical. So what do we understand by symmetrical? So if I ask you this question, the odds of diabetic foot among male is 2 times higher than female. Then what will be the odds of diabetic foot among female? How do we do that? Generally, what we do 1 divided by odds of male. So 1 divided by 2 will be 0.5 times lower than the male. Similarly, if I ask you a question, if the odds of diabetic foot among male is 3 times higher than the female, then can we say that the odds of diabetic foot among female is 0.33 times lower than male? Am I making sense to all of you? Are you getting this? How we are converting? So if you are changing the category, you just have to do 1 by that particular odds ratio will be the odds ratio in the another group. So you have understood. Very good. And similarly, we can answer this question like odds of diabetic foot among male is 4 times higher than the female. So can we say that the odds of diabetic foot among female is 0.25 times lower than the male? Yes. But again, you will see that this is not symmetrical. It looks very like I'm not able to interpret. If I only take it as a odds, then the interpretation of odds is not symmetrical. And again, like symmetrical, I can say like if in case of a continuous variable, if I say that the blood sugar of a male is plus 20 mg% higher than female, so we can say that the blood sugar in female is minus 20 milligram lower than. So it is symmetrical. What do I mean by symmetrical? Means the same value I can say higher, and in the other category I can say lower. But that is not the case here. Here if you say higher in terms of odd, then the lower is not the same. It's different. So Prashanta is writing how to change the odds of dependent variable. So it is only if you change the category, like if I say if you take the reference category here in case of a first example, that odds of male is 2 times higher than female. If you take the reference category as a male, then you do 1 by 2. You take that as a denominator. 1 by that particular odds ratio will give you the odds ratio if you change the category. Prashant, am I making sense? Did you understand? Like in case of this case, Pradeep is writing yes, but Dr. Rajesh is writing no. So this is a simple rule. If you change the category, your odds will be like 1 by that particular odds ratio which is there in the other category. You can calculate it and you can see it. It actually comes because the reference category changes. So that's why. So for now, you just remember it like this. You can go back and try calculating with any 2 by 2 table. If you change the category, your odds ratio will be like 1 by that particular value in the other category. So in this case, you can see, so this is not symmetrical. So now if you take a logit, because now I can see that this is the problem. Dr. Rajesh is writing, I meant for the other example. Okay. So, but what is the problem? The asymmetrical distribution of odds ratio around 0. So you will see here that if your study reported that odds of diabetic foot among male is 4 times higher than female, then I'll have to interpret that the odds of diabetic foot among female is 0.25 times lower than the male. So I'll have 2 equations. I'll have one equation for a diabetic foot male, and I'll have one equation for a diabetic foot female. So this will answer your question. Like here I am taking female as a reference, and here I am taking male as a reference. So here you will get 2 coefficients, one as 4 and one as a 2.25. If I am taking only as a odds. But I need only one equation for prediction because I cannot have these many equations for prediction. So if you take a natural log of this odds, then your 2 problems will be solved. By taking a natural log of this odds, you will have a minus infinity value and you will have a symmetry. So you will have only one equation. So if you take this logit or a natural log, and you all can do that. If you use a natural log calculator and if you start doing this, then you can see that natural log of this. You can all try doing that. What will be the natural log of 4? Yes, all of you please do that. What will be the natural log of 4? Or natural log of 0.25. So if you calculate that, if you use a calculator, you can do that. It will be 1.38. If you take female as a gender, and if you take the male as a reference, then it will be minus 1.38. So if you see that it has become now symmetrical. So that's why, yes, Parimita is writing 1.38. And again, Karishma is also writing 1.38. And if you take for 0.25, do it for 4 and 0.25 for both the values. Then you will see for one value it comes as a plus, and for the other value it has come as a minus. But the value is same. It is only the change of sign. Yes, we have calculated it, and it comes like this. So Asra, Paramita, Karishma, yes, agree. So now you have understood that if you take a natural log of odds, which is the logit, and this logit function is the link function which we were talking initially. So now I can replace that with the logit y is equal to logit b into x, and similarly all logit. So now it will be symmetrical. So let's again revise this, why we have taken a logit function and why it is being explained as an odds ratio, because linear regression is not possible with the dichotomous outcome. So we have calculated a probability, but when we calculate probability, it restricts the values at two extremes. So we have converted it into the odds, but odds has got one problem, that it is not symmetrical, and the other problem, it cannot go till minus negative. So we have converted odds, which is known as the logit function, log of odds, and this resolves the issue of asymmetric around 0, and then we have got a linear equation. So this is one where we will calculate this in JAMOVI also, don't worry, I'll show you. So this is the probability, this is odds, which is P divided by 1 minus P, and when you take the log of this, it will give you the logit function. So now you can see, if you focus on this here, so if you see this 1 or 0, so around 0, this is your 0.41, this is your 41, but again with a negative sign. So similarly, you can see there is a symmetry, and this symmetry helps you to have a linear equation. So that's why we have converted. Here you will see there is no symmetry, but here there is a symmetry. So now if you may ask, how does this software calculates? Yes, Dr. Mohammed, if we are doing logistic regression, because logistic we are only categorizing the outcome. So the how software does it, we need a linear equation for this prediction. So that's why it functions on the basis of that equation. But so we can fit our data on this equation. In background, it is calculating. That's why you will see the odds ratio as the output of logistic regression. Whereas you will not see a odds ratio in case of a linear regression. Those of you who have performed linear regression, you only get a coefficient there, adjusted and unadjusted. And then you get a p-value. There you don't get a odds ratio. But here in logistic, you always get a odds ratio. Why you get a odds ratio? Because of the problems, or because we are finding a solution of the problems due to which the assumptions of linearity is not met. And the assumptions of linearity don't confuse with the categorical independent variable. The assumption of linearity is for the dependent variable here. That's why we have converted that to a logit. So if there are multiple outcome, explanatory variable, how do we calculate this? So there is something known as the maximum likelihood technique. You just remember it as a MLE, maximum likelihood technique. What does this software does in the background, that it calculates the probability based on all the combinations. And then it sees like which is very nearer. Remember we talked about the residual in the beginning, like the difference between the actual and predicted. So in this case, it calculates the maximum likelihood. What do I mean? It runs in the background 50 to 20 iterations, and it sees that software which calculated probability is very much nearer to that actual probability. Means actual is only 0 and 1. There are two values. But the difference from those, if it is least, that is known as the maximum likelihood technique. And it calculates the probability where our residual is the minimum. Have you understood up till this point? How does it calculate the probability? We don't need to go into the background, but remember, what do I mean by this maximum likelihood technique? That it runs in the background many calculations, and the software sees that which is very near to that. Remember residual, and we talk about line of best fit, where the distance from the actual and the predicted value is least. So similarly here, because we are not talking about values, we are only talking about the probabilities. So it calculates the probability which is very near to that 0 and 1, because the actual probability is only 0 or 1. There is no value. 0 means that the outcome has not occurred, and 1 means that the outcome has occurred. But it calculates very nearer to that. Then Dr. Muhammad is asking why we are running multiple calculations. We are not running actually. It's done in the background. The software is doing it using the maximum likelihood option. So now let's do some actual exercise. If you add one more variable, like I'll show you over one Excel sheet. We had tried showing you one. So this you can see here. There are many variables. There is a gender, there is a preterm status like no NES, mode of delivery, normal cesarean section, Apgar score at 5 minutes, birth weight of the baby, and whether sepsis is there or not. So if there is a categorical data, then the probability, like if you calculate the probability, the variations will be less. Rather not the variation, there will be less of possibility. But for if you add continuous variable, then for each continuous variable, you can see there will be so many options and so many possibility and unique combinations. So it calculates based on all these combinations, and then it uses that particular like where the residual is minimum, and that's the maximum likelihood. And that's what I have written, that to calculate the probability of outcome for each the case based on the predictor value, the software first make an equation in the background, and it makes equation like this, and then it gets the best value of estimate for each predictor variable, so that each case can have a maximum possible value of probability, and that this software does it using a hit and trial method. So that was the background explaining the logit function and how we have come or evolved from linear regression to logistic regression. Now I am focusing on logistic regression per se. Means what are the assumptions of logistic regression? So till now, have you understood the basics, the background? These things are not needed for you to run the analysis. You will run the analysis, you will get the output, you will interpret it. But if you have that understanding in the background of how we have, like how this logistic is different from the linear, then maybe when you are writing and when you are analyzing your data, it will be like you will make more sense and you will try inferring more sense out of your data. So this variable is like those of you who are finding it difficult or maybe not able to understand, you can again, because these materials will be available with you, video and the PowerPoint. So you can again go back and try seeing it 2-3 times maybe. And once we cover the linear regression, maybe again if you go back and do it, then you will find it easier. So coming to the two types of variable which we use in the logistic regression, the response variable is also known as the dependent variable or the outcome variable, and the independent variable is also known as the explanatory variable or the predictor variable. So these are the terms, and with the help of the fewest predictor variable, if you want to predict whether an admitted newborn will get a sepsis, so again sepsis, yes or no, whether a family will fully immunize the child, full immunization status achieved or not, whether a mother will exclusively breastfeed her baby, breastfeeding, yes or no, whether a pregnant woman will have preeclampsia, yes or no, whether a patient will comply to treatment, whether a student will pass, or etc. These are all categorical outcomes which we are predicting. But there is a problem, because if there are many predictor variables, how to decide which predictor variable? So in case of a linear regression also, this question came like how to decide which predictor variable to take. So the first criteria is the clinical judgment. The second criteria is the value of p-value. So if you run unadjusted odds, we'll see what is the difference between the unadjusted and adjusted, and based on that p-value you take that variable. So you can see here outcome is there, but there are a lot of variables. There are so many predictor variables. So which variables to take? So you need to choose only few variables which you think that they are important for you and which can predict the outcome. So suppose if you have taken like on a clinical judgment, you have taken 10 probable predictor variable based on your best judgment. But again, I'm not sure whether I should take all 10 or I should do some, like I should allow the statistics to decide, to choose out of 10. Because if my sample size, again, there is a criteria of sample size. In case of a logistic, you want for each predictor variable, there should be at least 15 to 20 outcome, which has happened. So that's why there should be layering or sample should be there in each of these categories. Otherwise, we call it as a data sparsity bias. If there are data is less, then you will see that the odds ratio, the confidence interval of the odds ratio will be very wide. So that's why at least 15 to 20 sample means outcome sample should be there per variable. So if there are 5 variables in my data, at least I should have 100 outcome. And if your sample is so adequate, then only you can take these many variables. So suppose in that I need to do a univariable analysis where I will take dependent variable and then for each independent variable I'll take separately. And this is known as the univariable analysis. And then I will see the p-value. So I select only those variables where the p-value comes till 0.2. So that is the cutoff which we decide for the logistic regression. The same is there for the linear also. And why we take up till 0.2? Because there are chances that with adjusted and with a presence of the other variable, this 0.2 may become significant. And we'll see that. So the predictor variable, if it is a categorical variable or it is a continuous variable. So which type of difficulty I might face? So yes, I might face, like in this case, if you go by the chi-square, then for chi-square, yes, you are right. You cannot run a chi-square with a continuous variable. So in this case, you will have to use this logistic regression interface only. And for continuous variable, again, you need to check for the assumptions, like we'll see that there's something known as the multicollinearity. So these assumptions also we need to check. So that's why you will see many articles, they do this model prediction using only categorical variable. Because these categorical, if you have the categorical variable, then you will see that like a categorical variable, your interpretation will also be easy, and you can say that you need not to check few assumptions which you check in case of a continuous variable. So like in this case, you can see I have highlighted this good economic situation. This is a table showing the relationship of some variable with postpartum depression using logistic regression. So you can see there is a crude odds ratio. So what is a crude odds ratio? If I take only one variable as a explanatory variable, then that is known as the crude odds ratio. If I take more than one, then it is known as the adjusted odds ratio. So in this case, you can see here that the p-value here, they have not given it the p-value, but odds ratio is 0.38. But when I have taken it in the adjusted, the odds ratio has improved to 7.48. So that's why we recommend taking those variables where the unadjusted, the odds of unadjusted, the p-value is up till 0.2. So now I have selected some predictor variable for logistic regression, and then so which OR we will tell you, Tanveer. We'll tell you how to do that. I've still not come to the analysis part. So we generally either you give both odds ratio and we take adjusted odds ratio for deciding. But why do we do then unadjusted? You can ask this question. Yes, Tanveer? If we use adjusted odds ratio for interpretation, then why there is a need for doing that unadjusted analysis? Yes, any one of you can type in the chat box. Yes, Neha is right. It is. Yes, Tanveer is also right. So Tanveer is basically writing because in naturally, if you are taking all the variables, you want a combined effect. So that's why you are taking an adjusted odds. What do I mean by adjusted? Adjusted means effect of that variable keeping all other variable constant. Here I am not using interaction. So in none of, like in the linear regression also, I have not used a term which is interaction. Because interaction means like all the variables are happening simultaneously. But here adjusted means that variable effect keeping all other variable constant. And unadjusted means that only one variable. So yes, Neha was right. To decide which variable we have to take, you should run the unadjusted odds also. So like I'll come with the question. Okay, so logistic regression, we have done that, probability calculated. I have told you all this. And I'm skipping with this linear versus logistic. Now you know in which case when the dependent variable is categorical, you will run the this logistic. When it is not, then you run with the linear. So I think Dr. Shamshad is showing me the time. So I need to go with this demo. So there is something known as there are few more concepts I think which I need to tell. So unadjusted odds when there's only one independent variable or a predictive variable, and the adjusted odds when there are more than one independent or a predicted variable. Okay. Now there are few assumptions. Yes. So you need to check these assumptions, because if you have not checked for these assumptions, the model which you are making, that is not going to be a fitted model. So that's why you should mention all these assumptions in your result. So the first underlying assumption is that your dependent variable should be dichotomous. That we know that it is a binomial logistic. Definitely your dependent variable should have a 2 category. Then your independent variable should be measured either on a continuous or on a nominal scale. And then there should be independence of observation. That means if you have counted one person in one, then you will not count that with the other. Then there should be minimum of 15 cases for independent variable that we have talked. And there is something known as the linearity. So there is a procedure which is known as the Box-Tidwell procedure. In SPSS, we check for that. In JAMOVI, also we can check for that. But we are not telling you here now. Why? Because that's a little I should not say it's a complicated. That's a little complicated. So no, we in case of a in ordinal independent variable, we cannot take a ordinal. If you are taking ordinal, then it will behave like a you can say nominal variable. That is there. In linear also, if you are taking ordinal dependent variable, not the independent variable, you can take that. But the interpretation will be like, it will not be in that order. The software takes it as a nominal variable. I hope you understand the difference between nominal and ordinal. It will assume that all three categories are not related to each other. There are three categories. That means you can take polynomial variable or the polytomous variable, but that ordered nature and interpretation you cannot say. So that's the limitation of this ordinal variable as a independent variable. So now I was telling you regarding the Box-Tidwell procedure. That's a formal way to check for the linearity. But we have deliberately skipped that, and there are some other ways to check for the linearity, and it is using the model fit statistics and pseudo R-square statistics. And we'll see that if your model fit is significant, and if your pseudo R-square statistics is between 0.2, it's more than 0.2, then you can say that the overall, the logit function, that is, there is a assumptions of linearity. You can do one more thing. You can plot the scatter plot of the logit and the continuous variable. We'll see that. So there are three ways. There are many ways to check that. The very formal way is the Box-Tidwell procedure, but we are not telling you that. I'll show you three ways to do that when we'll go for the data analysis. And then there are other, like it should not show multi-collinearity, which we test using the variation inflation factor and tolerance. And then there are like outlier, which we check here in JAMOVI by the Cook's distance. And the value of Cook's distance should be less than 1. So this category prediction, we have learned that. And I have told you, like model fit statistics, like pseudo R-square, it is 0.2 to 0.4, which tells you the goodness of fit. And then there is a deviance statistics. And this deviance statistics is -2 log likelihood statistics, is also known as the deviance statistics. And there are two measures like AIIMS, AIC and BIC, Bayesian information criteria and AIIMS information criteria. So this deviance statistics tells you the badness of it. Why we call it as a badness? So there was one participant who asked in the beginning regarding the goodness of fit. So this model fit statistics you can divide into two parts: goodness of fit statistics and badness of fit statistics. This goodness of fit statistics, we see it by the pseudo R-square. There are three types of pseudo R-square that JAMOVI gives. We'll see Nagelkar, Cox, Nellen, and McFadden. And I think there was one more was added. And then there's a deviance statistics, which is the AIC and BIC. So we want this AIC and BIC to be very less. The less these values, the more good will be the model. Now coming to multi-collinearity, I think I have told you the variation inflation factor should be less than 10, which is the VIF. Then you can say that it is not collinear, means the if there are two continuous variable and there are independent, then there may be a chance that they two are very much linearly associated with each other. So if that is the case, then you can remove one variable. You can have one continuous variable. So I'm not going into this detail because then I think I'm skipping this and I'm directly now going to the data analysis. So I'll show you. This I have told you that VIF should be less than 10. And this Cook's distance is also for checking of the highly influential point. So if there are highly influential point, it will distract your model. The model fit will not be very good. So it should be less than 1. So again, to summarize, the continuous variable, the independent variable should be dependent variable should be binary. An independent variable, it can have a nominal or a continuous in nature. And then again, we check for that linearity assumption. We check it for the model fit statistics. Then we check for the Cook's distance. The Cook's distance should be less than 1. And then we check for the multicollinearity with the variation inflation factor. So these are the assumptions. And this we'll use this calculator net for using that exponent. So this exponent, which comes as a table, if you take the statistics, if you take exponent of that, you will get the odds ratio. We'll see that. So before I show you the demonstrate with the actual data set and question, the next, usually we conduct these webinars on second Tuesday. But this time, because of some other engagements, we are not possible to do it on the second Tuesday. So we'll conduct it on the first Tuesday, which is on the 3rd October from 2 to 3:30. And the topic will be the linear regression. Because ideally we should have done this before, but now we'll do this after this logistic. So the question which I have to solve, the model which I have to make, I have to make a prediction for the death using age, gender, race, cardiovascular disease status. This is the myocardial infarction order, whether it is a first order or a second order, type of MI, which is a recurring and non-recurring, and then BMI category, smoking status, and the baseline hemoglobin as a predictor variable. So let's run this in JAMOVI. So I'll go to the data set. So this is the data set of JAMOVI. And I hope all of you have downloaded the JAMOVI. And I think we have shared this data set also with you people. So you can simultaneously run the analysis also, those of you who have done it earlier. Here I'll explain the data set first. So this is the variable section. If you click on the variable, you can see we have taken the variable like age, gender, race, cardiovascular disease status, MI order, type, BMI category, smoking, and hemoglobin baseline. Now coming to the analysis. This is the data. So JAMOVI, in all the webinar, we say that this is a real time. It will show you the dynamic interface. On the same interface, you can see the output as well as the data. I'll go to the option of analyze, regression, and then there is the option of binomial regression. Okay. So analysis tab is here. You go to analyze, regression, binomial. If you click this binomial, you can see that you have got this view. So here you can enter this variable. So I have to predict death. So the variable of death is FStat. FStat means the status at the follow-up. Those who got discharged and those who died. So I have moved this back to this place. Now remember, we talked like we have to do the this analysis in an unadjusted manner. So how will I do? I'll enter first age here. Enter the age and I'll see the p-value. So if you see the p-value, it is significant. So I'll take this variable. So I have taken age. Now I'll go to the next variable, which is the gender. So I'm doing the 1 by 1. Sorry, gender I have entered by mistake here. Gender for factor, you can say you have to put it here in the second one. Here you can see the symbol of scale and flower. So this scale symbol here shows that you should enter the continuous variable in this box and nominal variable in this box. So now gender you can see the p-value is 0.03. This one. You have to see the value of this p of 0.03. So yes, I will take gender because it is also less than 0.2. Then I'll move this back to this window and I'll take race. Race again I'll take here. And you can see here the significance. So you can see the P is not significant. What is the P here? It is 0.8 and 0.6. It is not near 0.2. So I will not take race. Then I'll go with this CVD. I'll take this and then I'll see the p-value. So the p-value is 0.345. Should I take this or not? Yes, all of you. What is your opinion? Should I take p-value? No. Why no? Because it is more than 0.2. But still, yes, you are right. But still, if as a clinician, you think, no, I will take this. So it is up to you. But you should mention that in the manuscript, that you have taken this variable based on your clinical judgment. But generally, it has been seen that if the value is more than 0.2, the p-value, it never becomes significant. So then again, I have moved this back. Again, you can have this MI order. So what is the p-value of this MI order? So this is 0.45. So will I take this MI order? What is your opinion, all of you? Yes or no? Should I take this? Yes. So you said, so I'll take. If I go with this MI type, then it is 0.01. So yes, I will take this. I go with this BMI category. And this BMI category, you will see that both these are more than 0.8, more than 0.2. So I will not take this. And then coming to the smoking. Smoking, if I take, yes, you can see the p-value is 0.01. So I'll take smoking as one variable. And then you can see, I will move this back and I'll take this hemoglobin as one of the covariate. And then you can see that this value is 0.4. So again, should I take this or not? This 0.4? No. So what is my final predictor? There are only 4 predictors: age, gender, MI order, MI type, and smoking. So now I will enter all those 5 variables here. So I'll move age here. Sorry, it will not go here. And then gender, MI order, MI type, and smoking. So on the basis of that and unadjusted, no, I'm not taking, Dr. Rajesh is writing, basically you are taking all factors with p-value less than 0.05. No, for taking this in the model, the cutoff is 0.2. It is not 0.05. Because 0.05, though it is significant. But we increase this. We are slightly lenient because many times we see that with adjusted odds, a variable which is up till 0.2 can become less than 0.05. So that's why the cutoff is 0.2. So I have taken, fortunately in my case, no, we are not taking the p-value of intercept. There is no sense in taking the p-value of intercept. Intercept, it only gives you a constant. It's the basically the other thing which is the p-value of that particular variable which is significant. So now Senthil is asking, we find the significant value by using chi-square test. Yes, actually this is the chi-square. But for continuous variable, how will you find out the chi-square? So that's why if you use this interface also to calculate, that is also fair enough. Did you get it, Senthil? Because for chi-square, you need a contingency table. And if the variable is continuous, then you cannot calculate the unadjusted odds. Then Madhu is writing, why does the p-value change for chi-square and logistic regression? I have seen the difference. For categorical, so we have checked, we have not found out any difference. It's the same. You can again redo that. And for continuous, you cannot use that. And there's one more option in JAMOVI which will tell you at the end. It gives you the adjusted and unadjusted in the same column. I'll tell you, but let me explain the way, then all of you will understand. So now I have taken these 5 variables in the model. Then you can go with this. So you are writing for T continuous value, you will use to, no, T-test you cannot use because T-test is something different. It is different from this. So now t-test will not give you the odds ratio, my dear. It will only give you the difference in the mean value between the two groups. So now coming to the model builder, I'm not using this model builder because model builder is an option when you go for the hierarchical. So I'm not telling you the hierarchical because of the lack of time. Otherwise, if you go to the model builder and if you use the blocks, you can use the hierarchical. Now coming to the reference level, you can see here in reference, you can change the reference level. It gives you like alive and death. So the odds ratio which you will get, it will be for the death as compared to the alive. You will get the odds ratio in female. The reference is male. You will get the odds ratio for the MI order first, and the reference is recurrent. If you want to change this, you can get this as a recurrent. And for MI type, it is Q wave. And smoking, it will give you the reference. If you want the reference of no smoking. So if you want the probability like death in smoker as compared to non-smoker, then this will be the baseline smoking level. You will change it. Now coming to the assumption check. So remember we checked regarding the assumption. You can click on this collinearity statistics and it will give you the value of VIF. And this is the model fit statistics. Remember we talked like for linearity, we can go with this pseudo R-square value and the value of your deviance. So for deviance, this is the deviance AIC and BIC. This decides the badness of fit, and I want these values to be lower. And this is the overall model test, which I have clicked. There are 4 types of pseudo R-square. And this JAMOVI has added this Jude's R-square. I don't know whether we have not, we have found out today that this R-square is also added. Initially, we used to see the McFadden-Cox-Snell and the Nagelkar R-square. So I've clicked that. So before I go for the other options, you will see this is the model. This is the deviance. So what do we mean by 217? Maybe you can click, best is the Nagelkar R-square. So if I uncheck that, you will find that only one R-square. This is the AIC and BIC value. They are very high and they are important only when you have got 2-3 models and you can compare. So you can first focus on this. So you can see that the value of chi-square and the degree of freedom and the p-value. P-value is less than 0.001. That means it is a significant. The model is significant. And this R-square, I said if the value of R-square is between 0.2 to 0.4, then you can say that it is a good model, roughly. So it is more than 0.2, so it is a good model. I am not explaining this AIC and BIC because you see this with the, taking the reference of the null model. But I am not going into the hierarchical one. That's why I am leaving it for now. And then coming to the model coefficients. So coming to this model coefficient, you will see that this is the overall model coefficient value because we'll see that how to interpret. It will give you the odds ratio and the 95% confidence interval of the odds ratio. And then this prediction I am not telling you. Now, this is the ROC. I'll tell you. Let me explain the first one. And if these are the save option. So if you save this, you can see you can save the predicted values. It will give you the predicted probability. It will give you the residual. I'm not checking and it will give you the Cook's distance. But these variables will appear in the data. So if you go and click your data, you can see that there are 2 more variables which have appeared here. So there is an appearance of a predicted probability. So can you see what is the predicted probability here? 0.749. So if you see the probability of death, what should have been the actual? So do you find mismatch? Actual status is alive and the probability is 0.74. So what is your opinion? Just compare these 2 values. I just want you people to have a feel. See both these two data and what is your inference on these two. Case number 1 and case number 2. We are predicting death. Residual is high. No, first tell me it is a right prediction or a wrong prediction. Then I'll see. So first one, case 1 wrong. Agree? Because according to the predicted probability, this person should have died. And case 2, it is the right prediction. Why? Because it is 0.2. So remember, we have taken a cutoff of 0.5. Any probability less than 0.5, we'll say that outcome has not happened. And here the outcome is death. So probability 0.5 or more than 0.5 should have been died. And probability 0.5 or less than 0.5 should be alive. So similarly, you can check the other pairs also. You can see there are many here. In this case, it is alive. Again, 0.516. This one, but that is not very high. So all alive you can see in this case also. See this case? Both alive, but both have got a probability of 0.769. Yes. So 18, you are right. So this is how you can check. Now remember we talked about the Cook's distance. So you can see the Cook's distance here, and you can see here that none of the value is more than 1. So that means there is no data point which is outlier. So that you have checked for the assumptions. Now remember we talked about the odds and probability. So this was the probability, predicted probability. How I can convert it into the odds? So there is an option in JAMOVI. I just want to show one more option, which is the checking of linearity. Why this logit function has come, which we have learned in the theory. So there is an option of compute. So if you go to compute, I've used this option of compute. There are many variables which was created less. So I'll delete this. I'll delete this variable also because these variables, and then this 0. So this is my odds. I'm calculating odds from the probability. So I'll use a formula which Prashant told me. So I'll use this P. What is the probability? So I'll take this variable, which is the predicted probability. This predicted F stat. This I have taken divided by 1 minus that probability. So 1 minus again this probability. So if you see, this is your odds. This column is your odds. Now if you convert this into odds into the logit function, which is the log of odds. Again, you can go to compute and you can write it logit. I'm just showing you how this, you can confirm the linearity function. So there is a function which is log. So I have taken this log, and then this odds variable, you click like this, and then this is the logit function. Logit function. Now if I plot a scatter plot, you go to exploration, plot a scatter plot, and on x-axis, because I'm doing it with the continuous variable, so on x-axis it is the age, and on y-axis, if I plot with the predicted one, or let me plot it with odds, then see how this graph will come. You can see it is not in the form of a linear equation. It is like a parabola like this. So that's why if you like, instead of odds, if you take logit, which we have converted, then you see that it is in the form of linear equation. So did you get it? Now, can you have a feel now why we have converted this into logit? So now you have got all the three variables. You have got logit, you have got, and if you like, instead of logit, if you take probability, this is the predicted probability. Then also scatter plot, you will see that it is not in the form of a linear. as it was in the form of a logit. So with logit, it comes perfectly in the form of a linear equation. So what I did, actually, I used the option of save. And in save, you can have a data, this one, where I have calculated the odds using that formula P divided by 1 minus P for all these. And that I can do with this option of compute. And then I have used this log function of odds as a logit. And then I have plotted this graph. So this has shown that it is linearly related. Now I'll come again to the assumption, interpretation. So are you people clear up till this point? Then I'll move ahead. Am I making sense to all of you? Up till this point? Please tell how to do odds again. Okay. Odds, I did not do anything. I'll just show you. So this was the data. And there's an option of compute. So if you click this option, compute, I'll go to this. You can see here, I have used, there is a function. There's a drop down menu. If you click that, on the left side towards this, it shows you all the functions. You can have many functions here, but you have to select the variables from this. You cannot type like we do in the SPSS. So I have, because for the calculation of probability, I have to use the predicted probability. So that predicted probability is the predicted dash F stat in my variable. So I have calculated this predicted probability divided by 1 minus predicted probability. Remember, we talked about the formula of odds as P divided by 1 minus P. So same formula I have put here, and it gave you the odds for all the data set. And similarly, when I took the logit, so if you see this, there are a lot of functions here like exponent, log 10. You keep on scrolling and you will get a lot of functions. So right now I have used this log function for calculation of logit. Once you do this now, then it will be done. It is very easy. Nothing is there. Okay, predicted, I have not calculated, Madhu. If you go on click, and there is an option of save. Can you see this? So I have only clicked this. If you click this predicted value, you will get it. I have not calculated it. And that's why I have asked you, all of you, to do it simultaneously. If you do it, you will get it. Okay, so are you people clear up till this point? Then I'll go ahead. How to fix death outcome in reference? No, it is not you can change the reference level actually. You cannot fix it here. If you want like alive, then you can change it the other way around. But since I want to predict death, if you want to predict like who will be alive, then you can change the reference level. In that case, you can like reference, you can take it as a death. Then it will give you the like status as a alive, taking the reference as a death. Okay. But right now, since I want to predict death, that's why I have taken the reference as a alive. Now coming to the interpretation, still I have not told you the interpretation. So we have talked about this goodness of fit and this badness of fit. And then this is a likelihood test ratio. So likelihood test ratios also tells you the overall value, like which variable is significant. So you can see here, it will tell you that age and gender was significant. But the other variable, this smoking order, and this is not very significant in this case. I don't know what is happening. So you can see the value here. It is 0.64 and 0.132. This is not significant. Rest are significant. And the same you will find it here also. If you come here, this model coefficient which you get, it is through the Wald statistics. Here also you will see that these two variables are not significant, MI order and MI type. Now there is one more exercise for you people. So this estimate which you get, this is the estimate or the beta coefficient. If you take because then how will I have left one step, that if you take an exponent of this coefficient, you get the odds ratio, right? So there is an exponent calculator, and if you use that, you will get the odds ratio. So it's the, let me show you, all of you please do that. There is an exponent calculator. Please type that in your, let me show you. And if you type, if you take that exponent calculator, let me see if I can show. We can, let me. So if you type that, like, let me show you this thing. I will open this Merit India. Wait. No, it is not showing. Just a sec. So if I go to this is the exponent calculator. So see, this thing is, if I calculate this for gender, so it is 1.19. So if I write 1.19, E as a base, 1.19, and if I calculate, it will give you 2.28. So if you see this, this is 3.29. So it takes E as a base, 2. So I have not changed the base. So I have to change the base to this. I have to use like this, yes. And now I have to calculate this. So it is 3.28. I have to use exponent as a base. So if I use this 1.19, you will see that this is 3.29 is the gender, this odds ratio. Yes. So all of you can do that. Do it for this MI order minus 0.26. So if I use this minus 0.26 minus 0.26, and if you calculate 0.77, and you can see it is 0.77, this one. So basically this estimate, which you can, yes, which you can see here in this column, exponent of this is the odds ratio, because we have taken the logic, and if you take a exponent of logic, it gives you the interpretation as odds ratio. Again, you convert it back. So that's why exponent of this is interpreted as odds ratio. Now, how to interpret this odds ratio? So there is a continuous independent variable and there is a categorical independent variable. So interpretation would be different for each. So for age, if I say that this is significant and odds ratio is 1, how will I say? That for each year of increase in age, the odds of the person going to the death will increase by 1.105 times. But it is multiplicative. So in this table, Wald value is not there. Yes, this is the Wald value. This whole table, model coefficient, this standard error Z and P, this is the Wald statistics. It doesn't give you this value, but it calculates it in the that SPSS gives you with that name, but here this JAMOVI is with this name only. So you can see here that this is multiplicative. That means if there is a 3-year increase, then how will you interpret? How will you interpret if the person age is 3 years more than the another person? How it will 3.15. No. So that's why I said that it is multiplicative. Means you will, it is in exponent. So it will be like 1.05 multiplied by 1.05 multiplied by 1.05. So you will multiply 1.05 3 times. And that will be the odds of death for a person who is 3 years more. So 3 into beta, you can say here, right? So it is not 3.15, rather it is 1.05 into 1.05 into 1.05. Is it okay? So that 3 here, you put it as an exponent. So 1.05, like how I should... so have you understood, Prashant? It is not 3.15. And the rest of the people also. For continuous variable, you, like this 3 is, the 3 here, it goes as an exponent. So it is, yes. So no, it is not 1.15. So now coming to the next one, which is the this one, this 3.29. So how you interpret it? This is very simple, that the odds of death, like the females are 3.29 times more dying as compared to the male. And since these are not significant, so I will not write this. And for smoking, you can say that it takes this no smoker as a yes smoker as a reference. So if I want the death in smoker, I might go and change the this. So this smoking, I will take no as a reference. So if you change no as a reference, here you will see it will give you the odds of death in smoker. So odds of death in smoker is twice, it's 2 as compared to non-smoker. So this is how, and then you have to write in the assumption section the underlying assumptions also, and we'll see how to write it. So this was the table. In the table, you write the adjusted and unadjusted, both odds ratio. So unadjusted is also known as the crude odds ratio, and adjusted odds ratio is known as the adjusted odds ratio. And then you write here your, like I have written all the assumptions here. Okay, so Bhavna is still, Bhavna remembers. Okay, Bhavna, I'll show. I was about to show the same. Yeah. I'm sure. I told them that there is one option. So there is one option in the survival. So those of you who have not downloaded survival module, you can go with this plus sign here, and in the manage install, you can download the survival, which is the death watch. The even if you write survival, it will come. And then you can go to the survival, and there is an option of odds ratio table and plot. If you click this, and here what you can do, you can put their mortality or recurrence here as an abstract, and all the 4 predictor variables. So mine was age, gender, and then the other was MI order, MI type, MI order, MI type, and then smoking. These were the 5 variables. So you can see here that it gives you both the univariable and the multivariable. So univariable will be the unadjusted odds, and the multivariable will be the adjusted, and univariable will be the unadjusted. So then you can like put also this as a table. Then you don't need to go with that 1 by 1, which we have done initially, taking one predictor. And this also plots this thing something by pictorial representation, and you can see that the smoking and the gender and plus this age, these 3 were the significant. Others were not significant. So this was regarding the interpretation, regarding the getting the adjusted and unadjusted in one table, and the other options which are there. So I think it's so repeat only this. So it comes with the survival. Survival, you can go with this odds ratio table and plot and do it then. Okay, survival, show it again. So survival, I have downloaded the module. Go to this plus, manage install, available and all. This is installed. And then available since it is, so you can put like death watch. Or even if you put, see, this is the death watch survival analysis. Since it is installed, it is showing installed. So you can do that with your JAMOVI. And then you will have in this ribbon, you will have this option of survival. Click this survival and click this odds ratio table and plot. And if it comes, then again, just there are only two boxes here. One with the, for the dependent variable and then other here. Should be considered as a predictor. We have discussed this like 0.2. I have shown you one by one where the cutoff was till 0.2. You can go through the videos, those of you who missed in between, because video will be available to you people. And again, try doing it. Unless and until you do it, you will not understand, you will not remember. And this is something which you should do. Okay. So I think we can end here at this level. Yes, it will be available to all of you. And the next webinar is on 3rd. So,
thank you. Thank you, ma'am. Thanks a lot for the wonderful session. I hope all our participants had benefited out of today's webinar. We'll be sharing the e-certificates and resource materials to your registered email ID in a week's time. As ma'am said, our next webinar will be on October 3rd, not the Tuesday this time. It'll be on the 1st. The link of which we will be sharing with you shortly. As a part of today's webinar, I would like to invite Dr. Samshar Ahmed sir, Associate Professor of Department of Community and Family Medicine, AIIMS Patna, to deliver the vote of thanks.
Thank you, Venkatesh. Am I audible, Venkatesh?
Yes, sir. Yes, sir. Yeah.
Okay. Thank you all participants to be there for extended with this workshop. And we extended time. I think the first time we extended so much, 15 minutes, but it was needed, seeing the difficulty of this title or topic. So next time onward, we will make sure that if we are covering some difficult concept, we may in a prior inform that it will take around 120 minutes. But anyway, we will keep informing you about the next session. And earlier we did the basic sessions on JAMOVI, but in next successive sessions like October, November, December, we will touch the higher concept like multinomial, ordinal, logistic, and survival. So I request all participants to keep visiting on our website, and we will let you know also through various platforms. So thank you again for this wonderful participation and a wonderful interactive discussion throughout the session. Thank you all. Thank you, Venkatesh.
Thank you so much, sir. Thank you, Team Clarinet. We are closing now.
Thank you so much. Thank you so much, everyone, for giving us the opportunity to host this session. And we hope to have you again on our platform very soon. Thank you. Thank you so much.